Course agenda. Next, let's take a look at the course agenda. 1. Logic Design Fundamentals. In this chapter, we will cover basic logic gates, full adder example, simplifying logic functions with Boolean algebra, simplifying logic functions using Carnot maps, designing with NAND and NOR gates, hazards in combinational circuits, types of flip-flops, Mealy sequential circuit design, design of a Moore sequential circuit, state equivalence and optimization in sequential circuits. Key timing considerations in sequential circuits, tri-state buffers and their role in digital circuits. 2. Introduction to Verilog. In this chapter, we will cover key concepts in digital design, hardware description languages, HDLs, levels of abstraction in HDL design, benefits of using HDL, roles in HDL-based digital system design, challenges in adopting HDL, key features of Verilog language, basics of Verilog module declaration, Verilog module hierarchy and instantiation, port connection syntax in Verilog, connecting ports in module instances, using procedural constructs in Verilog, synchronizing module behaviors, naming, rules, case sensitivity and commenting in Verilog, simulating HDL designs, compilation, libraries, and elaboration. 3. Verilog data types. In this chapter, we will cover Verilog value set and simulation behavior, Verilog data types overview, Verilog net and register rules, Verilog port type rules, declaring vectors, assigning between different vector widths, specifying literal values, automatic extension of unsigned literals, variable vector selection, declaring nets, handling undeclared identifiers, net declaration assignment, resolving net conflicts, types of variables, integer and reg assignments, arrays in Verilog, declaring, module parameters, local parameters, and parameter passing. 4. Applying Verilog operators. In this chapter, we will cover bitwise operators, unary reduction operators, logical operators, arithmetic operators, enhanced signed arithmetic, shift operators, relational operators, equality operators, conditional operator, concatenation operator, replication operator, Verilog operator precedence. 5. Making procedural statements. In this chapter, we will cover describing module behavior, synchronizing module behaviors, interactions between procedural blocks, procedural assignments, conditional statements, case X statements, case S statements, while loop statements, for loop statements, repeat loop statements, forever loop statements. 6. Assignment types in Verilog. In this chapter, we will cover understanding blocking assignments, race conditions in blocking assignments, impact of blocking assignment order, understanding non-blocking assignments in sequential procedures, using temporary variables in sequential logic, managing multiple assignments in procedures, understanding continuous assignments, multiple continuous assignments, understanding procedural assignments, multiple procedural assignments, avoiding combinational feedback. Loops, generate statements in Verilog, generate statement, conditional if, generate statement, conditional case, generate statement for loop. 7. Simulation cycle. In this chapter, we will cover procedural blocks and event control, blocking procedural assignment, non-blocking procedural assignment, simulation cycle, 1 of 6, simulation cycle, 2 of 6, simulation cycle, 3 of 6, simulation cycle, 4 of 6, simulation cycle, 5 of 6, simulation cycle, 6 of 6, simulation cycle summary, Verilog timing controls, event controls, level-sensitive event controls, delay control, timescale directive. 8. Functions and tasks. In this chapter, we will cover Verilog subroutines overview, function declaration, calling functions, constant functions, task declaration, calling tasks, disabling tasks, issues and functions and tasks, automatic tasks, argument passing in Verilog, subroutine side effects, accessing module variables via subroutines. 9. Verilog compiler directives. In this chapter, we will cover using the define directive, using the ifdef directive, using the include directive, using the timescale directive, using the begin underscore keywords and underscore keywords directive, using the pragma directives, using the default underscore nettype directives, key Verilog compiler directives.